Dear subscribers, let us begin again and solve another numerical problem from engineering mechanics, problem set 2.6, solution to 2.89. Let me read out the problem first and look at the diagram also. Determine the forces exerted on the cylinder at B and C. Look, this is a cylinder. Its radius is given 63.5 mm. And this is a spanner A, B, C. This is a spanner. This is the handle. A, B is the handle of the spanner wrench shown in figure I. Due to a vertical force 222.5 Newton applied to the handle as shown, neglect friction at also B. Now to the handle here a vertical force is applied 222.5 Newton. And what will happen if you apply this force? The spanner wrench ABC will try to rotate this cylinder in a clockwise direction like this. If you apply a vertical load, this cylinder will try to rotate like this. So there will be turning effects, and this angle is given as 90 degree. From this point to this point is given as 304.8 millimeter. So there are 2 points of contact with the cylinder at B and C. So there will be reaction forces at B and reaction force at C. Let RB is the reaction at B, RC is the reaction at C. Now if you look at, therefore, the reaction at B, which is pointing to this side, passes through the point A. This reaction passes through the point A. Means the reaction force RB does not have a perpendicular distance from point A, so it will not produce a turning effect about point A. Clearly, RB passes through the point A and 222.5 Newton, the vertical force also passes through the point A. Now, the reaction RB and this vertical, they have the common point of intersection A. And if you can visualize, the direction of RB is to this side. I'm considering RB here by shifting it parallelly. This 222.5 Newton is to this side. 222.5 Newton. So the resultant of these two will be pointing in this direction. So for equilibrium, the reaction at C should be pointing in this way. That is directed from A to C. That is to be understood. So RC must pass through, the reaction at C must pass through point A, but pointing from A to C. Now the radius of the cylinder is also given 63.5 millimeter. That is from, if you consider this point as O, from O to C is same thing as from O to B. That is the radius of the cylinder that is being turned clockwise due to the spanner wrench. Now there is a redrawn diagram for you for better understanding. Look here, I have drawn the spanner wrench for you here. This is the spanner wrench. This is the point A where the vertical load is applied, 222.5 Newton. And from the center, this is the center of the cylinder. From the center of the cylinder to the point A is given as 304.8 millimeter. So as I just explained, the reaction at C must pass through the same point A, but pointing in the direction from A to C, RC. Now let this angle is equal to alpha. Why I have drawn this perpendicular, I will tell you later on. So let us find out BD is the perpendicular drawn on AC. means this is 90 degrees, so AB is the hypotenuse. So if you consider this angle is alpha, then BD is your perpendicular and AD is your base of the triangle. So in triangle OAC, important, in triangle OAC, this angle is alpha. So tan alpha will be OC over OA. So OC is given as 63.5, O is given as 304.8. So alpha is tan inverse of 63.5 over 304.8. That comes out to be 11 degree 46 minute 5.84 seconds of arc. Now then let us take the moment about point C first. If you consider point C, RC, the reaction force at C is passing through the same point. Means RC does not have a perpendicular distance, taking C as the moment center. So RC will not contribute any moment, means turning effect about point C. RC does not contribute, only RB contributes, and this vertical load contributes to the moment at point C. Then we must know the perpendicular distance of RB from point C and must know the perpendicular distance of this force from the point C. Now what is the perpendicular distance of RB from C as the moment center is now look, this is the direction of RB. Now 63.5 from C to O is 63.5. So this is the perpendicular distance of RB, the line of action of RB from C as the moment center has this perpendicular distance CO, that is given as 63.5. So RB times 63.5 is a anti-clockwise movement about point C. So that must be balanced by the clockwise movement, that is 222.5 times 304.8, because this is the perpendicular distance of this force from the moment center C. Now this force has this perpendicular distance, that is 304.8 from C as the moment center. So you take 63.5 to the right hand side, so you get RB is equal to 1068 Newton. And the rest are on the next page. Now then you again take the moment about the point B. Now for that you have to look at the diagram again. Moment about the point B. Now RB is a reaction force. This reaction force is passing through the point B, means this reaction force RB doesn't have a perpendicular distance from point B. Had RB been here, then there would have been a perpendicular distance. Had RB been here, then also it would have a perpendicular distance. But since it is passing through the same point B, RB does not have a perpendicular distance from point B, so RB does not produce any turning effect about point B. So the other two forces, they provide the turning effect. So that is what I am explaining. So RB does not contribute to the turning effect. Only RC and this Newton, they contribute. So we need to find out BD and AB, right? Now in triangle ABD, I have drawn a perpendicular. If you take sine of alpha, it will be BD over hypotenuse. That is this length. If you take sine alpha, it will be BD over AB. Now, sine alpha is BD over AB, And how much is AB? Is 304.8 minus this radius, and radius is given, that is 63.5. So your sin alpha becomes BD over AB. So cross multiplying BD is equal to AB sin alpha. AB is this much, which I explained. This is the radius, so sin alpha. So BD is found out. Now take the sum of the moments about point B on equilibrium. RC times the perpendicular distance BD. Look, this is the direction of RC, and RC is at this perpendicular distance BD. So RC times BD is a turning effect about point B. And what will be that? That will be anticlockwise, like this. Now, so that is what I have written. So this is anticlockwise, that must be balanced by a clockwise moment, that is the turning effect of this force about point B, and this force has a perpendicular distance AB from the point B. So now substitute the value of RD, which we just calculated here, put it here, and AB we have just calculated. So put the value of alpha, that has also been calculated. So keep RC on one side, take the other quantities to the right hand side. So this becomes this much. Put the value of alpha, put it in a scientific calculator. So this comes out to be 1090.9309 Newton, the reaction force at C. So the reaction force at C. So both the reactions are calculated. That is reaction at C and the reaction at the point B, where the spanner wrench is in contact with the cylinder.